Uh, Good evening, everyone. So we'll start today's session. I am Shobik, and I solved some of like one assignment we could not finish. Once I shared the screen. Yeah. So one assignment we did not finish at the last class. So we'll do that, and I'll solve the previous week's assignment, which you have the submission date is already over. Uh, Sorry, just some water. Okay. Uh, I hope you can see my screen. I'll just in the just I'll join for mobile so that I can see your chats. You can see chat it to the whole. Okay, fine. So the first question is as follows. So the first question is as follows. An airline has assigned each city. Hmm, sound is coming. Just a second also. Just trying to. Okay. Yeah. So an airline has assigned each city that it serves a unique numeric code. It has collected information about all the direct flights it operates and represented as a list of pairs in the form of IJ, where I is the code of the starting city or the departure station, and J is the code of the destination station. It now wants to compute all pairs of cities connected by one intermediate hop. That is, city I is connected to city J by one intermediate hop if there are any direct flights from I to K or K to J for some other city K. Okay. The airline was only interested in one of flights between different cities. Pairs from form II are not useful. Like it's same city, if it is calculated, it doesn't calculate. It doesn't care, right? Write a Python function, one of L, that takes input a list of pairs representing direct flights as described above and returns a list of all pairs ij where I not equal to j, such as I and j are connected by one hop. Note that it may already be the case that there is a direct flight from I to J. So long as there is an intermediate K with a flight from I to K, from K and from K to J, the list returned the function should include IJ. The include list may be in any order. Okay. The pairs in the output list should be in dictionary order. Each pair should be listed exactly once. Okay. So how to go about? So what this code basically wants to do, it's going about a very real life problem. So for example, it's a very real life problem. For example, if I just go and search in the flights, Google flights. One second. So if I just go and search in the Google flights, for example, what I will see is that so from if I want to go from Bangalore to uh, I want to go to Guwahati or say Gwalior. Okay, let's go Gwalior. Okay, and I want to say go on some day. Let it be any day, doesn't matter. I just want to see that what are the flights connected. Now, many times we will see that there will be one-stop flights. Okay. For example, so if I just get one stop or fewer, you will see that there will be multiple. There are some one-stop flights, right? Here is a one-stop flight. So, for example, there is a direct flight from Bangalore to Bombay and Bombay to Gwalior. So now we just so basically our airline, so Indigo airline wants to find. Okay, I have I have a flight from Bangalore to Bombay, and I also have a flight from Bombay to Gwalior. So we have these two flights. Okay, in my list. So now there are many cities. There could be from Bangalore to say I want to see it from say Bangalore to Delhi. Maybe any flight. Maybe New Delhi. No, it's not coming. For example, Delhi. So there are many non-stop flight and many one-stop flights. For example, this one-stop flight, it goes to Bangalore to Lucknow, then from Lucknow to goes to Delhi, something like that. So it has a list of lots of cities that are here in the list. Okay, and they want to find what are the flights that would be basically they want to find the one-stop flights. Okay, and give the if someone searches so that if that someone searches for a flight, we can see that what are the one-stop flights that are available, because many times you will see that one-stop typically you will see that one-stop flights are little bit cheaper than the non-stop flights, right? Correct. So how will you do that? Now, how do you do? So first what how do you think that it will be going? Okay. So first, whenever you get a problem, you first think it for some time that how it should go. What should be your basically the uh, theoretical procedure? Then you can convert the theoretical procedure to a code, and that would be quite easy at the time. So I have some cities, say I, J, K, and I have a list of say I, J, J, K. Okay, I, J, J, K, say K, J, I, K, like that. We have a list. Okay. Now I have to find what are the one-stop flights can go there. Okay. So now think that if a one-stop flight goes, if it's a one-stop flight, what will be the uh, equality? So for example, there is a flight from I to J and J to K. Now, if there is a common factor, this one, so the destination of sorry, not destination, my bad, sorry, the departure station of a pair is equal to the arrival station of another pair. If these two are common, that means there is a connecting flight between the sorry, I have just sorry, it's just opposite. I have said I'm sorry, it's just opposite. I was doing graduate. So the if the arrival station of one pair is common as the departure station of another pair is same. For example, in this case, both they are I and J. Then I can say that pair I and K can be connected to a one-stop flight. Is it clear? So basically, if we get some pairs like this, you have to basically find out which have the common. If the one element is common, the second element is equals to the first element of another pair. So second element of one pair is equals to first element of another pair. Then we can say that these two flights have connectivity. Is that clear? So if these two are equal, we can say that these flights are connected. Is it clear? For example, if I go to this and this, okay, or yeah, like that. Correct. Here, I think here we don't see any more things. So there is a only one stop here. Okay. Correct. And do we have anything else we can see? And yeah, we also have no, but this is not. And what we have to see that in that particular two pairs, this element and this element should be not equal. Because, for example, in this case, if you go to this case, though these and these are equal, but from it is just J or J. Here both of these are J. Though there is a K is equal, but both of these are J. So that means what we will get a pair JJ, which is not a meaningful pair, right? So this will not be the case. But if I go to say from for example, here if I get anything, I know here no more one stop is there. There is only one stop which is from I to K. Like that, okay. So how do you go about that? So in my understanding, if someone asks me to do this, I would do this in a dictionary way. So what I'll say, okay, get me all the pairs. So I like I'll have like a kind of a dictionary like this. I'll kind of have a dictionary like this. Say this is my dictionary where I'll have departure and arrivals stations. Okay. So for example, is in this pair I, J, J, K, K, J, I, and K. Okay, I'll first make a dictionary like this. Now what I'll do in the dictionary for each pair. Okay, for each of this pair, I'll just check. Okay, for example, if I go to each pair, for example, if I just take the departure station, say I. Okay, this is the departure station. Now, if that is equal to any of the arrival, is it equal to any of the Yeah, if it is any if it is there is in any of the arrival. J no 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 no. So like J no not no no no. So like that I'll do for similarly same thing I'll do for say for uh J. Sorry, this is for J. So I have got J J. Okay, I have got one J and J which has a departure and arrival is same. So what I can say that okay, there is a connecting flight from I to K. Then I'll again check no, no, no. Okay. So this is no. So no, this is IK. That's it. Sorry. This is uh, IK. Sorry. This is IK. Okay. So for them, I'll go for JJ. If this is J and J is true, but I see that though there is JJ2, yeah, I'll go like this, I'll go like this, I'll go like this, I'll go like this. Okay. That's what I have to basically see here, that if the arrival of a place is equal to a departure of a place. Okay. So how do I do that? Let's do it. So let's write the code. So I'll say that my okay. I'll just take this list of flights. Okay. So this one. So one of the examples they have given. So, list of flights is equal to, say I'll take this one, my input list. Okay. Now what I'll have to do? I'll def one, what is that written? One hop, something like that. One hop. Okay. Def one of some list. Okay. So def one of L. What should we do? Now we'll first make a dictionary of say flights. Equal to a dictionary. Okay. We'll say that okay. For flights in LST, which is my list of flights, LST. Yeah, LST if FL in FL flights. So it says the okay for FLs. Yeah. So this is, for example, this is my departure and arrival. So what I have to do, FL basically FL is there is a tuple. So how do you what do you say? Index the tuple? FL's 0 in flights dot is then flight just kits, then flights. This will be my key, right? This will be my departure station FL0 will be is equal to my FLs. This is my arrival, so FLs 1, because these are two elements 0, 1, right? Actually, flights is equal. Sorry, that dot happened. Sorry. Dot happened. Have to happen. I have to get a list. Okay. So instead of making the dictionary like I, J, so I would go from like whatever is leaving from I will get. For example, here I and K was there. So instead of making it like this, I will make it J and K. It's in a list. Okay. Like that. Okay. Append FL.1. This is the general the opposite case where when if it is not there, then what you have to do is equal to make a list and make a list with list. Okay. Okay. First, let's see how it looks like. Okay. I'll print it. Let print slides. Okay, let's print it first and let's see how it looks like. It's ran. See 2 3 1 2 3 1 1 3 3 2 like that. Oh no, this is list of flights. I have to. Oh, sorry. I have not called the function that. So one hop. What is my file? Okay. So it has printed like this dictionary, right? 2, it has 3, 4. 1, it has 2, 3. 3, it has 1, 2, like that. Okay. Now I got basically arrival and departure list. What I have to check that if always go back, I'll go back to here, this particular example. So now I have a list of this kind of thing. So if I have to just remake the list here again. So this is my departure. This is my arrival. So I have I, J, J, A, K, J, I, K. Okay. Now I will see, but basically I have to see that if J, which is the arrival station, is equal to the departure station for anything, correct? So for example, if I consider this J is common in both. So basically I have to check the equality between these two and equality between these two also. If these two is equal and these two is not equal, then there is a pair. Okay, that's what I am doing now. So what I'll do now, I have to do basically again what that is said iteration, a for loop again. So hop equal. So I'll make one more list. So this will be my one hop. Okay, this is my one ops. This will be what I want to get. So whenever this conditions holds true, that a departure. So if I say that, okay, a departure is let me think once. Whenever there is a departure, so first I'll go like I for I in J. Okay, I can go like this. That is a good option. That is a ideal option to do. Hmm. Okay. So what basically I have to do is first I have to iterate over this. Now, if I want to say for this particular one, now how do I iterate basically? This is a basic iteration. So first I have to iterate through this one and this. So I have to two iteration I have to do for this one as well as for each one, this one. Little bit complicated, right? It's getting a little bit complicated. So just to make you understand, say for I, this is my I, okay, this is my departure. So for each departure, there can be one or multiple arrivals. So for multiple arrivals, then I have to go and see and check that if this holds true. So for example, in case of I have two arrivals. Now for J, then I have to check in all the departure station that if those are true, then I have to see that if that holds true in that key, if the value is equals to this. That's what I have to see, right? First iterate through, first iterate over there, then iterate over this, basically. So if I write the code, it may be clear to you. So for example, for departure in flights, if for departure in flights, arrivals is equal to flights departure, is basically my key value, dictionary key value iteration. Okay, this is basically just dictionary key value iteration. These are my arrival stations. Okay. Or the arrivals, I just the arrivals. For stations in arrivals, if what I have to see that if that particular station is in this departure list, so that is basically the keys of the dictionary. So this is my flights dictionary. Basically, this is what? This is my flights dictionary. If this particular J is present in any of the keys, okay, in any of the keys, so if station actually, if station equals station in list of my flight source keys. slides dot keys, then and slides dot keys. Now, so this j if is equal to k. Now this is a list. Okay. So then I have to again go for that particular station also. Okay. So again, one more loop will go. So they say loop inside the loops I'm going. Correct. First inside this loop, then this will go to here, then this will go to here and check that if it is equal to here. So it's kind of like this. Okay. If I just do a control Z and clearly say you what I am trying to do. Yes. So this is my dictionary. So first from I to I'm going to J. Now I am J. From J, I am going to see if these are equal. So if this is equal, this is equal, this is equal. If this is equal here, then this is also a list. Everything here is a list, correct? Then I have to see here for each of them, and I'll see that if this is, so there can be k and multiple, right? If multiple times, if each of them is equal or not. So then that particular station. So for example, then for there could be there is station, there are also arrivals. So for ARR in flights, which is my key now. This is my key now. Station. If ARR not equal to ARR not equal to the depth, right? And not equals to depth, then pop dot append. Now what I have to append? So this will be my departure, and that will be this will be my arrival. So depth, comma. Is that my arrival? No. Sorry. This will be my arrival, right? Because I want to find this. So this is the ARR. This is the ARR, and this is the depth. Basically, in the code, the depth. This is the station. And this is my ARR. So I have to check every deep is equal to ARR. If it is not, then ARR. Okay. The print. Okay. Setlist.append takes only work argument 2 as given. Oh, sorry. List.append. So I have to give this. I have to append a tuple. Okay, it's saying none. Oh, I have not returned anything. Sorry. Return. Okay, I have got lots of things, but I have mistakenly done them. Okay, so I have not got what I have wanted. So there is some mistakes I must have done. Okay. 2121. Okay. Okay. There is some mistake I have done then. Okay, no. Here, this one I have used, right? So 121314. Okay, so there are first of all there are multiple things. One of this. So in these cases, okay, if you want to remove the duplicates, there is an easy way to do it. That is using, instead of using list, use a set. Okay. So there is something known as, there is also a type of container that's known as set. Okay. So set is a basically a another type of. So if I now go do this, you will see that if I now again run this, yeah, it's actually, you have to go it. Sorry, I cannot do it actually here. So what I have to do is set. Yeah, set is a function. So if I do a set of hop, what we will do is you'll see that this thing will, so before returning, basically I'll print the hop and so that you can understand the what I'm actually trying to do. So set is another type of, what is happening? Set print hop. Okay. If I now see, you will see that 21 was here. 21 was here, but here 2121 has gone. So there is only one. Then there were other but there are other, no, there is only one set was do I say one set one, there was one duplicate only, so that this duplicate has been taken care of. So set basically, if I make a set of this, so sets are generally uh, sets and dictionary, though both have starting syntax same, but but whenever you are writing something like this, you can understand 1 3. Okay. See, it costs only 1 2 3 4, and whereas there were multiples, and sets are not always sorted. So for example, if I, instead of making it like this, if I say 4 4 like this, you'll say that, yeah, so like that. Also, if I say this like that, okay. So yeah, so basically I'm making the hop as a set. So, and I'll, because they have asked me to sort it. Okay, so I've got it sorted hop. Is it correct? 1 2 1 3 1 4 2 1 1 2 1 3 1 4 2 1 3 2 3 2 3 2, sorry, 3 2 3 4 4 2 4 3. Correct. Let's try with this one. Let's try with this one, the second one. See, it has printed 0, and I'll remove this particular print statements from here. Okay, yes, one, and this one I'll print. So just for understanding. Okay. So this is basically looping after looping after looping and looping. So basically, it's just a assignment of understanding how loops actually work. So you have to practice, just for you to practice how loops work. Okay, the loop. So basically, I'm first doing a for loop here, then doing a for loop here, then checking this. So basically, this. Okay, okay. So like that. For example, if instead of this one, if I how it actually looks, can yeah. So this I have printed, right? Ah, this I have printed. Okay. So if I just copy this one, this particular part, if I copy this a dictionary, okay. So it will be more clear. Ah, so if this with this particular example, if I do the same thing, like draw a departure and arrival table, till what I'll find. So I'll get in my departures, I have 2, 1, 2, 1. So these are my keys 2, 1, 3, and 4. Correct. What are my arrivals for 2? The arrivals are 3, 4. And that is a list. For 1, I have 2 and 3. For 3, I have 1 and 2. Okay. For 4, I have only 1. Okay. So now when I'm doing that first thing, that is when I'm doing the first one, that is that dep in flights. So first my dep in my first one, my dep is basically 2. So this is my dep. So dep is 2. Now for dep arrivals, so this whole list. Okay, so basically this is my dep. Okay. For the first loop. This whole loop is my arrivals. Okay, so whole list is my arrivals. Okay. For station is in arrivals. Now for station is arrivals. For my first station is this is my first. So I'm just trying to show you the first run. This is my station in arrivals. If station in list of flight dot keys. What is the list of flight dot keys? So if your whole thing is list of flight dot keys, correct? A list of all my flight in this keys. Okay. Now for station in list of flight dot keys. If station in list of flight dot keys. So this is my station. Now 3. Okay, this is my 3. So it is there in my flight dot keys. In which one it is? The 3 is in my flight dot keys. Now what is my flight substation? So this is basically my this particular thing. So this is basically flight substation. Correct? This particular thing. What is my first ARR? Which is my first ARR now then? So if this whole thing is flight substation, this is my first ARR. Anyway, so this is my first ARR. Okay, one is my first error. Now what I am checking if ARR is not equal to departure. So if I'm saying that if ARR is not equal to departure, no, ARR is not equals to departure. Correct? So 2 and ARR. So departure not equals to ARR. So what is my departure? 2. What is my ARR? 1. So if these two are not equal, what I am doing? That my hop dot append. So I am appending these two pairs. So 2, 1. And you will see that 2, 1 is there in the list. Okay. In the second loop, my second station will be station. This is my station. So 1. This will be my station 2. In the station 2, this will be my first. This will be my flight. This will be my I'll check that if station 2 in it, then key. So this will be my second one. Will be my second one. If this is my second one, then this will be my flight start station, and this will be my ARR 1. So again I'll check that okay if 4 equals to 1. If 4 not equal to 1. If 4 is not equal to 1, then again I should get yeah. So this is my here this is if this is my ARR 1, this should be my ARR 2. Okay, this is my ARR 2, and if again I say dip, what is the depth? Depth has not changed yet. Depth is still 2. So 2 again not equal to 1. So again I'll get another what else? Another one, that is 2, 1. Okay. So another I should get is 2, 1. So that's how I got 2 times 2, 1. Correct. Because there are 2 stops and both of them are there. So I got 2. So this is again, this will be not considered. So like that it will go. For 1, it will be like this. Okay. For example, if 1 will get 2, 2 is equal. So we'll get 1, 3. Correct. Then 3, 3 is equal. So we'll get 1, 1, which will not hold true. We'll get 1, 2. Okay. See, we got 1, 2, and we got 1, 3. 1, 2, 1, 3. It's clear? Okay. So yeah, this is basically a quite complex. Like it seems to be very complex, but it's basically just simple looping and dictionaries. I hope it is clear to every one of you. Okay. Anyone has any doubt? Anyone has any problem in understanding? No, right? Okay. Okay. So we'll go to the next one. We'll go to the next one. So whatever we got is correct. 2, 3, 1, 2 is much more easy, I think. Okay. So if I have to just go and say 2, 3, 1, 2. Let's see what happens to this. There is a departure arrival. Two and three and arrival 3, 2. Then there should be also okay. Now there, see now when I've tried this particular problem, there is a problem in my code itself. Okay, it's not always correct. It's correct only, but there is some problem still now. So here is a case where we have a ik and kj, but this seems to be wrong, right? Ik kj. So if there is a from flight from I to k and k to j, but here it is a flight from 2 to 3 and 1 to 2. Oh, this is another case. So here is we have a flight from 2 to 3 and a flight from 1 to 2. So then, but yeah, this should also give me. Oh, I'm getting it right. Have I printed it? Okay, sorry. That's why it's going like why it is okay. That's why it was having problem. Now it won't have. 1 3. Okay, correct. So 2 to 3 and 1 to 2. So basically it's just opposite written. So this and this is same. Yeah, it's correct. Okay, I got confused because I did a mistake, small mistake here. I got 2. Okay, this is also correct. Okay, so our code is running for all 3 problems. Okay, and I'll instead so I'll stop this one so that it's clear. So 1 to 1 3 and 1 3. Okay. Okay. So our first problem is done. And we'll go to the one of the problem that was in last week's session. I think week 8 it was there. Okay. Given a tuple t, create a function square t that accepts one argument and returns a tuple containing similar elements given in tuple t, and it squares the sequence. Okay. See, if I get 1 2 3, I'd get a tuple of 1 2 3 1 4 9. How to do that? Now, if that was a list, it would have been easier, but tuples are immutable, right? So we cannot add or uh, remove things from tuple. So for example, if I want to say this is my tuple, say 1 2 3, I cannot do dot append say 1. No, tuple of no object or attribute also, but we can do no. We cannot also do. Can only concatenate tuple, but not int. Okay. So what was the problem here happening? Basically, if you just type type, so basically one element one is considered as tuple. Now there is a trick here. Just if you add one comma, it becomes a tuple. Why? Because this comma is now considered as a character here, and is kind of thinking is as tuple. So for example, if I was getting this error, right? If I do this, it will work. So I can concatenate tuple with tuple. That's it. We got what I have to do. So what we have to do? So def square T, which will take a tuple T. Right. What we'll have to do? For I in, actually I can do, I don't have to do a, what I can do is, should be a one, if I do a list comparison last week, I have asked too many, I have explained you list comprehension. So this time I'll do it in a list comprehension way. What do we have to do? We'll do like this. E plus E, sorry, I into I, or I in E. Will it work? Let's see. What will I get? If I say print, this won't even call the function. Square T of okay. So basically it's not concatenating the generator itself. So what we can do here is, and just I can do here is, instead of making this square is equal to this, so T plus SQ. Concatenate tuple node generator. What is basically SQ? Okay, this is kind of a generic. Do this also. Yeah. This will work, but I want to do it in a other way. So one way is to do this. So for example, if I do this, I can do in one line. So basically, yeah. So basically, this is the one liner. So basically, I'm first getting a list using a list comprehension, making a list, converting it to a tuple using the tuple function. So if I so its tuple function is just similar as the list function. So tuple of 1, 2, 3 will give me a tuple like this. If I say tuple of 1, it will say me into object. So again, I have to give like this. Okay. So see 1, 1, comma. Okay. So like that. So it's basically one liner. So return T. That is I'm just concatenating two tuples. Now I'm concatenating the T. What is this one? Plus list comprehension, which is converted to a tuple. So return T plus tuple of list comprehension I into I for I in T. Because I have to do a square. If I instead of square, I have to do cube. So basically, this would be a better way to do. Okay, one liner. Okay, this is the Okay, next one. Given a string S, write a function replace V that accepts a string and replace the occurrences of 3 consecutive vowels with dash in that string. Make sure return and print the answer string. Okay, let's see. So I have my function replace V, which take a string as my variable. I'll show, sorry. What is replace V? Now it will get me a string. So first of all, I will define the vowels. So that we can define in the outside. So vowels, like, sorry, VOW vowels is equal to A, comma I, A, E, I, O, U. So A, E, I, O, U. Okay. A, E, I, O, U. And so I think there could be, I was thinking in another way, there could be also the case of the character also could be important. So what I have to do is I have to make a similar thing with like this. A, E, I, O. Okay. Just to check the capital letter as well as the small letters. So what you want to replace now? Replace A and HELL with U. Okay, with just a dash. Okay, so we have to use a counter here. Correct. Have to use a counter. How will you use the counter? Now again, I will go like I'll just go to the rough coding. So first theoretical thing. Theoretically, how will you do that? Okay, so we have a thing like this. A this. So first what I have to check? You have to check if a character, if it is vowel or not. Secondly, if at that position, if the vowel counter is, what is the vowel counter? So what it should do, it should say, okay, in A previous, so I should initiate the counter is equal to 0. At A it is a vowel, so counter should go to 1. Then again A, a vowel, counter should go to 2. Again A, counter should go to 3. Now as soon as counter is 3, this would be replaced with a dash or like underscore, sorry, underscore. Now and again the counter will be reset back to, again the counter will be reset back to 0. Correct? Now after that at H it is a consonant, so counter will again stay at 0. E is a vowel, so counter will go to 1. L is a consonant. So counter should again go back to, sorry, counter should then again go back to 0 because that triple count is now lost. L, again a consonant, counter will remain as 0. Okay, counter will remain as 0. Now O, so 3 vowels. So again counter will go like similarly. Counter will go to 0, 1, 1, 2, and 3. It will go to 1, 2, and 3. Then again, this will be replaced by underscore. Correct? Clear? So whenever there is a consonant after the vowel, the count is not equal to 3, then the counter should always go back. Otherwise, if you keep this counter at 1, what will happen? At this position, it will consider this as a what do I say? As 3. So these 2O or this actually this LO will now get replaced. And how will we replace? So basically, we'll say that okay, at this particular, now we have to use the index. So if at this particular index, if the counter is equal to 3, then from this index to its last previous two index, I minus 2th index should become 0. Now how and now how the indexing works, because for that instance this is Python, the indexing has to be actually from I minus 2 to I plus 1, because then only it will consider from I minus 2 to I plus I minus 2 to I, right? So easy, right? So for car in S, if car in vowels, oh sorry, you have to make a counter, right? So the counter is equal to 0. If car in vowels, then counter plus equal to 1. If counter equals to 3, what should I do? Actually, I have to see the index. Either I can use enumerate, like for index or character, which I prefer to do. Index comma character in, because it's easy for me to follow up the index. Otherwise, you can do len of range of len of s also. That would also work. Same. So what I have to do if counter is equals to 3. So basically I have to replace things. So what I have to do is this for this one. For this one, basically I have to, for returning the results, so I have to get first start the result with the empty string. And if the character is in vowels, I have to basically append the character also, right? Res plus equal to, because I have to get the result also. I cannot change s directly itself, because otherwise this thing will become problematic. So res plus equal to the, if the count is equals to 3, then res, sorry, yeah, counter is equal to 3, then what I have to replace? Res idx minus 2 to idx index plus 1 equals to an underscore. Okay. Else sorry, elif or else what I can do. And yeah, this, and we have to make the counter again equal to 0. Counter is again is equal to 0. I'm again making the counter and just do else. Don't need elif. Else this thing will be same for a consonant. If it is a consonant, character will of course get appended. But again, we have to make the counter equals to 0. Equals to 0. Okay, that's what I was explaining to you. And yeah, and finally, what you have to return? Return res. So if I now return res, and now I print, you see what happened. Replace v. What is my s? Say yeah, this is my s. Okay. And if I go, okay, trim string support. Oh, sorry. It's oh, okay. So what I made res was as a string. Okay. Now string I cannot replace. So what I have is equals to I cannot do. So what I have to do, dot. No, sorry. In string. Yeah. So raises. So what I have to do is raise dot. There are two ways. Raise dot replace. Now what does replace? Replace takes two options. So what I have to replace? I have to replace this with this equals to raise dot replace. So I'm replacing this part with a. Now this will work. Oh, this has not worked. Okay. Okay, there is something I'm missing in the. So there is a basically the. Oh, sorry. This will be index minus 2. That's why it did not work. Sorry. Yeah. It worked. Okay. So what I'm doing here, basically I'm checking the character, and here basically result equal to result dot replace. I'm replacing, this is a string. I have to use, I cannot use that this particular thing option. There are two ways to do this. I'll show you. So I'll say that okay. Res dot replace res of index this particular part, which is that AAA with just a dash. This is one way to do. Another way to do it. You can do it in this way, of course. And another way to do it, you can make as this as a list, and result is equal to plus character. Okay. Here also plus character instead character. And you can then say that okay, res of, you can just say that equals to this unmatched bracket. Yeah, equal to this. This is another way you can do. So basically you are making the each of the item as a list character. So if I print now, this will happen. Now what we'll have to do is dot. So I'll join all the I'll join all the elements of the list without any space. This is a character. This what happened? Hmm? This should work. List doesn't have. One second. If I'm doing some mistake. One second. List is a list or join function as far as I remember. Oh, this string dot join. Uh, all join list. Oh, sorry. Yeah, I was making in the sorry. I was keeping the syntax opposite. So yeah, sorry. That's why I think this is. So basically, I have to join res without any space. Yeah, this is another way to do it. Okay, I prefer the last way because it's simpler way with the last one. This is a much simpler way. Okay, we get the same result. Not the other way. So there is one problem I can identify here. See, this should have one space instead of that. There is, I think, three uh to three underscore append. Why this should happen? Okay, let's see. So we'll debug the. We'll first debug the code. Let's see. So A is a vowel. Now counter is equal to 1. You can keep your eye on here. Okay. Counter is now 3. Should replace 1 and counter is equal to 0. Okay. Now it's the age. Counter is again now 3. Say counter is again counter is 1. Okay. So this is the problem. Here is the issue. Okay. Now this is the vowel. Now this is a there is the issue. There is the vowel, but even if there is not the vowel, the counter is now 1. Okay. If the result is equal to character, counter is equal to 1, but counter is not equal to 3. Okay. But still, and now the counter starts with 1. Now if I go to L, it will counter. Oh, this will be again making the counter 0. No, it's okay. Again making the counter 0. Okay. L O, correct. O, counter is equal to 2 now. Now finally counter is equal to 3. Now what is this now? Sorry, what is this now? What is my index now? Index is equal to 9. This is quite confusing now. What is my IDX? IDX equal to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have to say 9 minus 2, which is 7, 7 to 10. Seven to 10. This is the last index. So very odd. What is rest now? Yeah, does LL. Okay. Hmm. Yeah. Did you find the error? Did anyone find the error? What is the error? There is a very cheeky error. Okay. Small error that we have not thought of. Anyone? The error? What is the error here happening? That's how you if you don't see the result, that's how you go and see how the code, why the code is not working out properly, right? If it is there and anyone can find out. Very small error. What is the character size after the replacement becomes? So the index of res basically changes because the index and this basically because here is 1, 2, 3 now at this moment there is 1, 2, 3, 4, 5, 6, 7, 8 characters. But what is the but I'm following the index of actually S. How many characters in S was there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters. So basically, instead of this, I have to do S of this one. What I am replacing? Replacing basically S is this part. What part I am replacing? I'm replacing OOO, right? So if I'm replacing O, O will if I go to the index actually goes to here. This is the index, correct? So this is the if now if I see now if I do, we'll see it's correctly running. Why it is doing that? Because I again do this. Yeah. Now if I see the index is 9. So now if I say this is oh it what is called? Ignore this particular thing. This is not related to this NV. This is some other module is installed. That's why. So this is now O. You have to follow the index of S, not the index of res, because res's index will change. Okay. And the last program, last one we'll do for the day. We'll stop here after the last one. This is also one more interesting question. Write a program that take list L as input and shifts all zeros in list L towards the right by maintaining the order of the list. Also print the new list. So basically, if there is a 0, 1, 0, 3, 12, we have to make 1, 3, 12, 0, 0. How to do this? We don't have to make a this it's not a making a function, right? But we have to make a function. If zero mover. Okay. You guys think and say how do it's done? Okay. So how I think you can do it in multiple ways. There are multiple ways in the way to do. So how I thought to do is to uh, first remove the zero from the list and again add it back at the end. That's how I thought of doing it. You can do it in any other way. Okay. So what I thought of, like, first remove zero, this zero zero this zero, like remove, and then add how many times I have removed the zero, add like that. So what I did was, counter is equal to, say, zero. I'll make a first start the counter as zero, while while zero in, say, this particular while, sorry, it's a L, so list will be, while zero in L, make the counter plus equal to 1, and L dot remove 0. Now return L plus 0 into counter. So this is I what have thought of. Zero mover, if I move this one. I don't know how you people have done this. Okay, remove subscription. Oh, sorry. I'll not remove further the function, right? First, I should keep it in a. This is the what I thought of doing. I mean, I don't know if how else you can do. There could be you can use list comprehension also. So how to do it in list comprehension? So this I what I have thought of. Now I'm thinking of in other way also. So if I think of some other way, like way one, so I'll not turn it. This is well. So this is way one. Way two. See def. What I'll say that zero mover def zero mover two is um I don't know I have how to do it. I am just trying to think it of. Okay. Return. Just want to make it in a one liner. Hmm. Is a type of function is equal to is only weight equal. I'm just forgetting this thing. Else zeroth index. I think there is some move. There is a I think there is something on a move. If I'm just move an element in a list. There is so something called list dot move Python. Just trying to figure out release dot move in Python. Okay. So one list comprehension would be there is one list comprehension is such that so what way I can do is uh remove this one from here and then again add it back to the append. So return in a list comprehension return uh, L dot pop Yeah, I'm actually also thinking this one how to, since we have some time, can think of. So this is of course a correct way. You can, if you have done like this way, you'll get the marks. But if I want to do list comprehension way, so what does list.pop do? List.pop is returns an item. Pop returns also this item also be present at the given index, also removed from the list. Okay. Return the last value. Oh, removes. I think it's if you say the index, if you say the index optional, the value index removed, it's not given. Okay. L dot pop dot idx dot append I for I in uh, for idx comma sorry for idx comma I in enumerate. I got it. Oh, sorry, I have not got it. I don't know if it as well. No, then int object doesn't have any int. Can I do that? How to do that? Index if I equals to 0. But it will give me an error. Int object will append. I'm just thinking how to do it. Actually, I have to create something with I. So in a list comprehension, I first want to pop no, I am not able to think it out. Remember which I want to do it. Since I have already done it in this way, this thinking is not coming to me. Anyone has any idea how to do it with list comprehension? You want to really want to do it with list comprehension in one line. Anyone has any idea? Uh, okay, if I say okay, I for IDs come. If I do this, it will give me only zeros. Hmm. No, I'm not able to do it. Just not able to think it off. Sorry. Uh, no, I'm not able to. I was, yeah, trying to, but I'm not able to. List comprehension, I won't think it will work. There are other ways, but list comprehension, I don't think only in list comprehension it won't work. Okay. So anyway, let's focus on this and let's do it on this way only. If I can think of something, then I'll see if I can do. Um, there's one way also I can think of making, if you are just want to make it in using list comprehension. If I not equal to see is the just the same way len of L minus it's not this. I can think of like this in using list comprehension basically. So mm, L plus 0 into this should work. What is answerable type list plus list? What happened? Oh, sorry. Minus len of yes. 0 into okay. I have to give brackets here properly. No, no, sorry. Actually, I have to go with this. No, anyway, it's not working. I'm trying however, whichever I can, but I think there is some 0 into len of. So basically, okay, I'll just tell you what I want to do. Basically, I want to it's giving me some odd things. Okay, yeah, I was just trying to think like think that if I can do a length kind of count, but that doesn't mean that doesn't mean, that doesn't work. This is much easier way to do it. Okay then. So yeah, so I could not make anything else. So yeah. Okay, thank you all for joining. So we'll stop here for the day and I'll share this all of this. So I thank you for joining.